Hi, this is Wes Overton, and today we are going to go over our lesson with closure with polynomials. So some people may or may not have heard of closure, but the idea of a number system being closed is like if we take whole numbers, if we're trying to see if it is closed to addition, will a whole number plus a whole number always equal a whole number? And that is, of course, yes. And what we want is, if it is closed, provide an example. If it is not closed, provide a counterexample. So here you can go 5 is a whole number plus 1 is a whole number, gives us 6, which is a whole number, and that is an example of that being closed. And we're looking at whether they are closed to addition and really subtraction, multiplication, and then we're going to look at a few number systems if they are closed to division. So with odd numbers, if you took 3 plus 1, that's an odd plus an odd, gives you 4, which is an even, so therefore it would not be closed, and this would be a counterexample. So this works really well with students in groups with the mini whiteboard, so you can flash the number system, give partners or groups a chance to think about it. They will determine yes or no, and they will write their counterexample or example. And really the main one we are looking at is polynomials, which are closed to addition. So I could take like 5x squared plus 2x squared to give me 7x squared, and it is also closed to multiplication. I could take 2x times x plus 4 to give me 2x squared plus 8x. Now what happens is when we get to division, that's where they are both not closed, and we make that connection between integers and polynomials, just like we did when we were multiplying polynomials. We started out with integers and showed how that was really the same process but using polynomials. So here we would be providing a counterexample. So if I take 5 an integer divided by 10 another integer, I will end up with 1/2, which is not an integer, and it could be the same idea. If I take x divided by x squared, I will end up with 1 over x, which is a rational function, but not a polynomial, because that would give us x to the negative first power. So this lesson helps us look at standard 7 in the Algebra 1 with probability. Right here we're showing that polynomials are just like integers, and they are closed under the operations of addition, subtraction, and multiplication, but not division.